Hi, my name's Eric, and today I'll be talking a little bit about AC induction motors. The alternating current induction motor is a device used to convert electrical energy into rotational mechanical energy. There are many great minds that laid the groundwork for this creation, and the fundamental design that is used today for AC induction motors was created in the 1880s by Galileo Ferrari and Nikola Tesla. The induction motor is used by inducing an electromagnetic field in the stator section of the motor. As that field rotates, the rotor spins with it. It is used in almost any application where rotational movement can be utilized. It can also be set up reverse as a generator by spinning the rotor shaft along with the proper circuitry in the stator. It will produce electrical power. The induction motor has a wide range of use. It's used industrial almost everywhere, including food processing, packaging, distribution centers, and virtually any process application. There will be AC induction motors found somewhere within that process. They can be used on conveyor systems, fans, mills, really anything that you can use rotational mechanical energy. People may not realize it, but AC induction motors can be found around the house as well. They're common in refrigerators, vacuum cleaners, power tools, air conditioning units, and similar types of motors can also be found in children's toys and power windows on your car. AC motors come in all sorts of sizes as well, from small motors that could fit inside your pocket to ones that are much larger than a human being. Generally though, an average industrial 1 horsepower motor is approximately a foot long by 6 inches in diameter. Shapes can vary in these motors, however, they're normally cylindrical shaped. The weight of these motors can vary quite a bit as well, from under 10 pounds to thousands and thousands of pounds. The average 1 horsepower motor though usually weighs around 40 or 50 pounds. It's pretty solid and fairly rugged in design. The outer housing of an electric motor is usually made of steel or a composite material. Internally there are windings usually made up of copper wire, and the rotor here is usually a steel shaft with either aluminum or copper lines for the squirrel cage. The outer finish of these motors usually varies from manufacturer to manufacturer. However, they usually are painted or coated in some fashion to keep them insulated. Generally, the parts of an AC induction motor include the motor frame here, which usually has mounting feet of some sort and a wiring box. And on the inside of that frame is the stator section, or the windings of the motor. Also, the stator is where the rotating electromagnetic field is created, which is followed by the rotor, and on the rotor is a squirrel cage, which is essentially bars of aluminum or copper that are highly conductive and follow that electromagnetic field. If this motor was configured as a generator, the rotor would spin and those bars would actually cut lines in the magnetic field, producing electrical power. Lastly, we have what some people know as the end bells, which are the bearing housings that hold each side of the rotor shafts, and they ensure that the rotor sits centered within the motor housing, and they can either be removable or they can be built in as all one piece on the motor frame. Electric motors are used everywhere. Their uses are only limited to our own ingenuity. From industry to home use, electric motors are a mainstay.